Gestalt psychologists also realized that the knowledge and experience that people bring to solving problems also played an important role in how successful people are at solving problems. And indeed, your own knowledge and experience and the type of problems you've solved in the past um, can have either a positive or a negative effect on abilities to problem solve. One example of how our own knowledge and our own prior experiences and the things we know might affect how we approach problems is the so-called 9 dots or 9 stars problems. The problem is that there are these 9 asterisks that you see in front of you, and you must, with only 4 lines, you must connect all of these asterisks. And so the typical solutions that people come up with, they might start from a point. Let's say, let's take this asterisk down here. So you do 1 line, 2nd line, 3rd, and a 4th. And then you realize that you've missed one. So people often say, okay, so I've missed one. So let me just start from the center and see if I can do any better. Since as I was going around the perimeter, that didn't work. So let me start from the center, and here we go. And 1, 2, 3, and 4, and I'm still out of one. And essentially, people very often keep trying to develop these kinds of solutions. And you might have noticed, as I was proposing these two solves, that there's an implicit hypothesis. In fact, there's a mental set that is going on, and I'll define that in just a second. But you might have noticed that I have assumed that the boundaries of the solve have to be somehow within the perimeter of this shape, so that the lines have to stay somehow inside of this image. But of course, that isn't said anywhere. And in fact, the right solve, you can get to it only if you break free of this assumption. So one way of solving it is the following. You might start up here, and you trace 1 line, 2, 3, and 4. And now with only 4 lines, we've managed to capture all of the asterisks. But as you see, it's just so tempting to assume that the boundaries of created by the 8 external asterisks are the relevant boundaries of where I can trace my own lines. And until you break free of this mental set, you cannot really get to the correct solve. Now, as I was saying, this, and in fact, even the, even the candle problem and the 2 strings problem, these are all examples of mental sets. So a kind of a frame of mind that involves certain representations of a problem or certain representations of the object inside a problem. And these might cause you to be inefficient in finding a solution. For example, the mental set in the context of the 9 asterisks, as I said, is the silent assumption that your lines have to be drawn somewhat within the bounds of the 9 asterisks. In the case of the candle, the mental set is just the fixation on the fact that the matchbox is a matchbox and is not something that can contain anything. So there's that kind of mental fixation. And of course, the same is true in the 2 strings problem, where the tools that are here, in fact, the hammer that is on the table right here, of course, it's a hammer. And until you stop fixating on its particular function, which is that to hit objects, and you that way allow yourself to reframe it into something else, like a weight that allows you to turn the 2nd string into a pendulum. So until sort of these mental sets are preventing you from finding the correct solution. And indeed, they do tend to express themselves as silent assumptions that you make without really realizing it. You know, that the hammer has to function as a hammer, that a box has to function as a box, or that the boundaries of the relevant solution are within, you know, the boundaries of those 9 asterisks, et cetera, et cetera. And of course, the more we have these mental sets, and typically we derive these from our own knowledge, the harder it is to reframe, as the Gestalt psychologists say, the problem into a new way of thinking or into some kind of new representation that might allow you to solve a problem. And indeed, many of these ill-structured problems typically require some kind of change in mental set, some kind of re-representation in order to lead to the insight and to a solution. Now, one good example of the effect of mental sets. Now, the book gives you the classic example of the water jug problem. So I'll just give you a slightly different version of the same thing. Now, this experiment goes as follows. You have these matches here, and if you're not familiar with Roman numerals, this is an equation written in Roman numerals. That would be 3 = 9 - 1. Now, the experiment goes as follows. First, you see a number of problems of type 1. For example, I give you this, or rather, you're shown this, equation right here, and your job is to find a way so that you can turn this equation into something that is meaningful. Obviously, 3 is not equal to 9 - 1. So how can you manipulate this expression in order to make it meaningful? Well, one way is to notice that this 9, ix, can actually be written as IV just by moving one match. And now this would be 3 = 4 - 1, which indeed is 3. So this is what is often referred to as chunk decomposition. The fact that you can see the number 6 as 1 and as the 1 before the 5. So this way you can solve the problem. And what I do as the experimenter, I'll give you a lot of problems of this type. For example, I might give you a second one, which goes like this. So let's see, this one is 8 = 6 + 4. So definitely not a good solution. But of course, I could just, again, if you think of this 6 as being done of a 5 and a 1, you can just invert the 5 and the 1. And now you have 8 = 4 + 4, which is correct. And so the whole point is that throughout the first half of the experiment, I keep giving you this type of problem. And in a sense, what I'm doing is I am creating in you a specific mental set. I'm creating in you the expectation or the mental set that you can typically solve problems by manipulating these Roman numerals. And so if you instead of seeing this as a 6, as you see it as a 5 or as 2 Roman numerals that you can sort of manipulate, then you can typically solve the problem. And as long as I keep giving you the same problem, you do pretty well. So in this case, mental sets are very helpful. However, as soon as I give you a problem that requires a different mental set, people typically start struggling. For example, if I gave you this, so 6 = 6 + 6, obviously this doesn't work. How can you resolve this? Now, once I've trained you to do problems of type 1, what happens is that people typically, because they've entered this mental set that they have to somehow use chunk decomposition, so they have to somehow manipulate the different parts of the numerals in order to solve this, they try finding a way in which they can move a match to sort of to change this 6 or that 6 or this 6 into something else that would make this meaningful. However, of course, an equally good solution is to just do this: 6 = 6 = 6. And see, the trick is that here, you're not manipulating the numeral, you're manipulating the operators. And after I've taught you, after I've created in you specifically the mental set that you can typically solve the problem by manipulating the numeral, it becomes harder to suddenly switch and start thinking about the operators themselves as also being amenable to being modified in order to solve the problem. And similarly, I could give you yet another problem, which again requires a manipulation of the operators. So for example, 9 equals 6 minus 3. That doesn't really work, but I can simply move one match across and turn this equal into a minus, this minus into an equal, and now I would have 9 minus 6 equals 3, which is indeed correct. However, turns out that empirically, after you've trained someone on a specific mental set, while it helps them solve faster problems of the same type, so problems for which the mental set is good, they really struggle if the way in which, if the mental set required to solve the new problems is now a different one. So this is a good example of how mental sets can be a big obstacle to solving problems.